Alright. Okay, pay attention everyone. So let me start with, what is the purpose of immune system? Purpose of immune system. Okay, immune system purpose. So it's recording is little bit straightforward, okay? Others, if not, it will be noisy, useless to recording. Yes. So you said for defense. For defense, is this the only reason? For defense, in a sense, you want to kill the microbes. That is what your statement, right? To kill the microorganisms. Any other purpose of immune system? Yes.
Antibody production.
Antibody production. Okay, so Shubham saying antibody production, which is also a part of killing microbes. Any other things? Regulation of?
We won't kill the healthy cells at all.
Oh. So Mr. Raman giving a new statement. He is saying that regulation of what you said?
So it won't kill the healthy cells.
Okay, so he is trying to say that it won't kill it will kill only the microbes or bad things, but not self or healthy cells. A very interesting statement. Well done. He is saying that immune system will regulate to maintain the healthy cells and it might kill unhealthy cells. He might try to say, right? Is it possible? Our own immune system attacking our own cells, our own unhealthy cells. Is it possible? Yeah, that is possible. Well done. Actually, cancer cells. Okay. Our immune system can be able to identify our own cancer cells and it will try to kill the cancer cells, even though they are cells. Not only outside organisms, but within the cell, within the system, it will identify the abnormal parts or abnormal cells and it will kill them. Need to be tightly regulated. If this self-attacking got misbalanced, if self-attacking capacity of our own immune system got unregulated, that leads to autoimmune disorders. That we'll discuss later. That is very interesting. Since someone said, I'm also writing one more thing. There is a dedicated system called HLA or MCHC system that I will discuss later. Major histocompatibility complex or MHC. Yeah, MHC. Okay. Or human leukocyte antigen. Any other purpose of immune system? Any other? Phagocytosis. Okay, this is for Muskan, I'm writing. Phagocytosis. What do you mean by phagocytosis? Eating of a pathogen by a macrophage can be stated as phagocytosis. This will be done for the killing of microbes. Just writing here. Not all cells can able to do phagocytosis. Only few cells can do phagocytosis. Can you guess what are those cells? Macrophage. Then neutrophils can do that job. Then basophils. I guess any more? B cells. Very interesting. What we thought previously about B cells? B cells will produce antibodies. But B cells can also contribute in phagocytic action. Okay? Now listen, based on this phagocytosis, the immune markers are broadly categorized into two types. This is a new term for you. Keep in mind. I am saying immune identifying marker. It is not marker to be precise. Just keep in mind, phagocytic cells has MHC2 molecules, and all other cells has MHC1 molecule. Very, very important thing. All other cells has MHC1 molecule, whereas macrophages has MHC2. What is the significance of these two? I will discuss later. All other cells, nucleated cells has MHC1, whereas only the macrophages have MHC too. I think Mr. What is his good name? Avinash. Why are you smiling? There is something very interesting. Then don't smile. Yeah, fine. Phagocytosis. Any other functions of immune system? Huh? Hemostasis. A very broadest term for regulation again. Homeostasis is trying to say. Homeostasis. Regulating all normal things. One of the things is immune regulation. Any other things? Functions of immune system? Huh? Maintenance of immune memory. That is again a common statement. Maintenance of immune memory. Mr. trying to say that if we got exposed to one pathogen, our immune system will memorize the pathogen. Second time, if that pathogen coming, it will kill it. So maintaining the immune memory. Agreed. Any other functions of immune system? Excellent. Everyone appreciate Muskan. Transplantation. For transplantation rejection or graft rejection. Graft rejection or graft acceptance. Okay, that is it. So that is called as for transplantation we need this immunology. Any other things? Other applications, uses of immune system? Very interestingly, I will give you the answer. Try to justify it. Immune system will also maintain the genetic diversity. How is that possible? Immune system will maintain the genetic diversity in the population. That is my statement. Genetic diversity means, not everyone will have same genes. It will try to maintain variety of genes in the pool, in the gene pool. How immune system contributes to genetic diversity? Through adapting now. Any guesses? Do you need one answer? Clue? Clue will be, it's a pregnancy complication. No guess? HDN. Or erythroblastosis fetalis. Erythroblastosis fetalis, what happens in erythroblastosis fetalis? If the mother was negative, fetus was positive, first fetus delivery leads to sensitization in the mother. Now mother develops antibodies. If the second fetus is unfortunately a positive fetus, the mother will kill the baby. Here we are seeing blood grouping. In blood grouping also we have antibodies, which is an immune system. Why? Maybe my question should be, reframe. Why we have blood groups? Why there is no single, only one blood group among humans? Why we are evolved to have multiple blood groups? Maybe we are evolved to maintain various types of genetic pool. If we are getting same groups or that positive negative, the mother eliminating those species from the gene pool because she wants diversity. Maybe Mother Nature required the diversity among them, and the diversity can be maintained by immune system. Why do we need diversity? When we have more diversity, there are less chance of getting mutations in the offsprings. When you are having diverse gene pool, if everything is same, high rate of mutations. Let all people have different types of mutations. So when gene shuffling happening during birth, they will be nullified. So yeah, in a way, immune system maintaining the genetic diversity. Immune system maintaining genetic diversity. Very interesting thing. Okay. Yeah, self from not self or these things. Now, any other applications of immune system? Surveillance. That's the overall motto of immune system, to keep us protected. Yeah, any other things? You want to say surveillance? So surveillance in a sense, not surviving, but surveillance. Can you justify your statement?
Always check up on the bodies or
Surveillance. I will write this one. Maybe Aman saying surveillance capabilities. So immune system constantly surveilling the types of things that are entering or going outside in the body, not only inside the body but also in the environment, by maintaining genetic pool, by birth rates, and by eliminating species. Yeah, it's a hindsight. Immune system, from the behind, without the involvement of genes, still able to categorize the gene pool. Very interesting. Maybe it's surviving the nature, or when I say nature, the particular geography. Any other things about immune system? Very interesting answers. I didn't expect that actually. Any other applications of immune system? Any other? Can you draw a few more things from transplantation medicine to connect it with the immune system? So, immunocompromisation. What do you mean by immunocompromisation? What is the significance of immunocompromisation? Significance and pros and cons. What is immunocompromisation means? Immune suppression. Immune suppression happens in HIV, right? The immune system will be suppressed. Immune system become weak and prone to other infections. Now there is one interesting area called immune tolerance. Very, very interesting. Immune tolerance. What is this tolerance? I hope you know the word, meaning of this word tolerance. Something we are tolerating even though we don't like it. That is called tolerance, right? We don't like something but we are tolerating it. Like this weather, right? We can't escape from this cold weather. So we are tolerating it with our warm clothes. So similarly, haven't you ever thought about this one? See, there is a father genes and mother genes combined together to make a new gene pool, a new baby. Now, new baby is entirely a different candidate from our system, from immune system point of view in the mother, or take it just to think a sperm. It's not even developing a baby. Sperm is someone else, foreign, not her own system. Okay? How can, if that is the case, in the cervical and vaginal cavity, when there are macrophages who are constantly surveilling to attack the pathogens, sperm cells are foreign objects. Got my point? To the mother. Then how she is accepting the sperms? So there should be some involvement where the immune system must be compromised in the vaginal cavity or in the cervical cavity. If not, it can, the birth is not possible. Somehow the immune system has tolerating an external intruders for a better cause. Okay? Now, this same survival advantage also become a weak spot, something that is prone to infections. That's why there is a common vaginal infections among the women. The reason is the overall immune system is compromised in that particular area to maintain, that depends on your menstrual cycle and your ovulation and estrogen progesterone along with the immune activity. All these things are interconnected. And that is why women are more prone to vaginal infection or opportunistic infection, because that is a normal flora, but normal flora can be able to cause an infection. So we can't escape from that cycle. It's a normal flora, but when your immune system compromised, you are getting a discharge. The reason is immune system compromised based on your ovulation, based on the entry of the sperms. So yeah, so that is one biological weak spot we have. That is due to immune system tolerance. Then there are some hijacks to this immune tolerance. Can be able to adopt, can be able to make a body to adapt to something. We can be able to train the immune system to get it tolerated. I will give you one best example. There is one famous movie, some 30-40 years ago in my Andhra. The hero was a villain You know what I mean? Yeah. So what happens was his father was a snake man. You know, he used to do this snake game, okay, real snakes. So constantly from his childhood onwards, his father giving a drop of venom to the baby since his childhood. So the baby started, you know, the hero, so-called, villain or hero, the baby started tolerating the venom. Okay? Every full moon day, he will become a snake and he will go for, you know, this thing. The thing was, here, when you are training the immune system with some foreign object for a long period, immune system will tolerate it. You become resistant to that particular poison. So in that movie, one person will try to, you know, kill him by an actual snake, but he will be alive because now he is a snake. He tolerating venom. Yeah, that is there any survival advantages of immune tolerance? Is there any applications of developing immune tolerance in a patient? Yeah, there are some survival advantages, such as after giving a transplantation, there is a high chance that her immune system won't tolerate the graft, the organ. So we need to how to counter solve this issue. One thing is we need to give some drugs to suppress her immune system, but that is the case, she is prone to more opportunistic infections. But the good thing is she will accept the organ. So what to do? Rather than doing this suppression of immune system, can be able to train her immune system to the intruder, to the transplanted organ. So now there is this wonderful therapy called CAR-T therapy, CAR-T cell therapy, that I will discuss later. Very interesting, CAR-T cell therapy. What we are going to do was, we are using chimeric T cells actually, antigen recombinant antigen T cells. If Shubham's transplantation, I'm going to give it syrup, I will take Shubham's gene, Shubham's immune genes. The genes are in MHC actually. Now, I will inject his genes in the Shirup's T cell. I will take Shirup's T cell and I will genetic reprogram the T cell to tolerate or to accept his tissue. After I'm engineering her cells, I retrain her body, her immune system to tolerate this transplantation. After 2 to 3 months, I will go for transplanting his organ, and it will be a successful transplantation. Bypassing the matching, bypassing the fingerprint matching. Usually we need donor matching. We are doing HLA typing. We can bypass this HLA typing by training our immune system. So that can be achieved by CAR-T therapy. This person got Nobel Prize not now, in 2012 or 13. So it's been almost 12 to 15 years old discovery. Very interesting. That person name, I don't know, but I need to cross-check. Anyway, so these are few facts about the immune system. And today we have CRISPR, where we can literally train the immune memory to against anything. That we'll discuss later. Yeah. So with this I will start today's lecture. This is just introduction. Yes. Classification of immune system. Classification of immune system. Actually, I desperately need this subject, but they gave that. Yes. Fine. Now, by the way, you should not disclose this with the actual faculty. Okay? Never. Okay. It won't look good. Yes, Multasim, you want to disclose this? You should teach your own thing. You are getting paid for what you want to teach, and why not teach others? Fine. Listen. Immune system. Yes, Geeta. Is your immune system fine? Then why she is turned that side? Okay. Fine. Where am I? Apart from Gita, a classification of immune system. Yes. So immune system is broadly categorized into two types. Okay. Specific immune system and non-specific immune system. Okay. Non-specific immune system and specific immune system. I will give other names. First I am giving layman terms. Non-specific means even if your organs are not compatible, I want to harvest all your organs and I will distribute to everyone. Simply. Non-specific immune system. See, this is a type of immune system which is also called as inborn immune system. Inborn immune system. Or it is also called as innate immune system. Now you know what is it, right? Innate immune system. It is non-specific. It will protect us from everything. That is called the innate immune system. Can you guess what are those normal innate immune system parts? Skin. Very good. So it will, it will protect from everything, from environment, everything. Very good. Skin. Then mucous membrane. So wherever there are orifice, that means holes. So all these orifices are covered with mucous membrane to trap the dust particles. Very good. Mucous membranes are there. Hair appendages which will act like a stroking off or brushing off the dust particles. Hair appendages. Okay, I agree. Hair. Nails. Yeah. Nails. No, I'll keep that aside. Vitreous humor. Tears. Okay. Tears. Vitreous humor. Tears as a part of innate immune mechanism. Saliva, okay, exit. Saliva, next, sweating, okay, okay, then, any other innate? HCl, maybe you are saying gastric juices, all juices in the GIT. All GIT juices, enzymes are in the juice. Where is this should be today?
Yes, sir.
Oh, is there? Okay, fine. I thought I was expecting him there. Yes. Next, where is Keshav? Dear. No comments. Let him be comfortable where he is. Apart from sweat, gastric juice, any other innate mechanisms? There are many interesting mechanisms. Innate. I'm speaking. Saline. Cilia. Cilia is given at the cellular level pressures. Cilia, villi. That become an anatomy now. So be general. Don't go to anatomy, cellular anatomy. Villi. Any other things? Tonsils. Since he erased the tonsil term, I want to justify the class point. See, wherever there are mucous membranes, in the mucous membranes trapping the pathogens. But now, mucous membranes need some support. If the pathogens are too high, they alone, the enzymes in the mucus alone cannot destroy the pathogens. So now what they did was they kept a little police stations across the mucous membrane areas. Those police stations are called as lymph nodes. Those nodes, in that lymph nodes, there are dedicated types of cells, macrophage cells, ready to attack in those, just like police in a police station. So we have those police stations, and one of the police stations are nodes present in the oropharynx or tonsils. When you get an infection, the nodes will become enlarged because the infective agent was attacking inside the node. So tonsils, I will take that as one point. Actually, if you want tonsils, you should say lymph nodes, lymphatic system and lymph nodes. That I will discuss later. Obviously, in the lymph nodes, they have multiple white blood cells. It has many things. Yeah, neutrophils are part of it. This one. Okay, she is trying to say neutrophil non-specific. Let us discuss that in the cellular thing. We'll see later. Fine. Then, fine. Then, since since Diksha said neutrophils, maybe I should categorize innate into multiple types: cellular level, mechanical level, and systemic level. Then I need to take others. At cellular level, innate can be done by neutrophils or white blood cells, to be precise. Okay, all are non-specific actually, not so precise. Then I just want any other innate mechanisms. Any other innate mechanisms? Placenta to protect baby against everything. Okay, very good. Okay, placenta. This is an interesting answer today. Very good, Shobham. Placenta can be acted as a innate barrier for everything. Yes.
So amniotic fluid.
Amniotic fluid. Since you say placenta, I will give credit to it. That's a filtrate. So fine. If that is the case, all fluids, CSF, everything is. No. Keep that I said. Any others? Placenta created only during pregnancy, but placenta cannot go, when you say pure specific, it's not going to specifically protect against HB, TB, HIV. It will protect against everything. So in that sense, it's a common protective barrier for the fetus in a pregnant woman. So yeah, it's an innate barrier, correct. Not a specific barrier, but a common barrier to protect the fetus as a whole. Yeah, any other? Very good. Placenta is nice answer. Anything else? Piyush, Muskan, Ronak, or they are googling to get new answers, right? If that is the case, I will be happy. If not, I will redistribute your organs along with that chip. There is a distributor club. Anything else? Okay, then I need to enter here. Body temperature. Temperature is an innate mechanism of, killing microbes. Whenever there is an infection, the body temperature will rise. Actually, increase in temperature is a good mechanism. You should not take paracetamol when there is a slight fever. Let it be. Fever is a survival mechanism to kill the pathogen, because this bacteria has a very small proteins, and those proteins can be easily denatured by increasing their normal temperature, optimal temperatures. So body purposefully increasing the temperature to denature their proteins. So body temperature. Body temperature. pH, need to be very, very cautious. We don't have such mechanism of targeted acidic pH in one area. If that is the case, blood buffer system. No. Saliva, that we'll give that to the particular organs. There the pH is maintained, but not as a whole. pH in a very indirect mechanism. Okay, I will give, but not directly. Next, pH is okay. Fine. Anything else? Inflammation. Inflammation is an outcome of ongoing attack by the immune system. It is also part of innate. Oh no, pushy when that inflammation I will take it actually. That's an innate only. Inflammation. Well done. I think this is the significance of 6th semester. You will have better understanding. Well, next.
Please justify that. How is it like
Yeah. See, for example, let there be any random parasite entered into the circulation. Now the eosinophils came. They are not going to check what parasite is it. Eosinophils came. IgE antibodies came. They will bind to the eosinophils. They will release the histamines and prostaglandins. Histamines, prostaglandins causes nearby blood vessels to dilate. Dilated blood vessels permeable mode. The fluid will be, go to the extracellular spaces, leading to a edema or inflammation. But it is a non-specific immunoactivity. It is a result of to a non-specific pathogen. So when I say specific to one particular pathogen, my statement when I say specific to Tinea solium, specific to leishmania, specific to malaria. In this case, eosinophils will be respond to any parasite.
So, should we say eosinophils or should we say inflammation?
Inflammation is an innate mechanism facilitated by eosinophils, which is a common reaction, immune reaction. That I will discuss, don't worry. That classification I will go here, don't worry. I will come there. Cellular, I will discuss. Anything else? Since Miss is right? I need to give a separate classification to remove these confusions. I will take this point. You remind me later, okay? I will do another classification apart from this to justify your confusion. Any other reasons of immune? Blood grouping is a type of immune. Blood proteins. What blood protein you are trying to say? MHC is a molecular marker, not a protein. Since she said a protein, obviously there are some proteins in the blood. Excellent, since you said the word. The proteins are called as complement proteins. Complementary system. There is a dedicated immune system which we are not studying in +2, but there is a different world that is called complementary system, complement pathways. Just like 13 clotting factors we have almost 23 to 30 complementary proteins dedicated for killing. So that I will write. So proteins, blood proteins in a sense, complementary proteins. Complementary proteins will do one vital role, opsocins. We are saying, right, this macrophage pathogen will release some chemicals, PAMs, and macrophage got attracted towards the pathogen. Actually, there are some molecules called C3b molecules that are directing the macrophage towards the pathogen, and C3b is a type of complement protein. That I will discuss later, that's very good. Any other things? Allergic reactions. Allergic reactions is a part of specific actually that I will see later. Now things getting mixed here when we are going that. I'll leave it here. I will conclude innate in 1 minute. See, other things are species specific immunity. From species factors, maybe I need to say what factors contribute to innate immune system. One factor was species. This is there in your CP Biology textbook. Species specific immunity. What do you mean by species? See, a big immune system developed in such a way that it can be able to survive in a very unhygienic environment, but not humans. From species to species, the immune capability differs. Okay. If you take birds have a high body temperature. Do you know that? Yeah, warm blood actually. Birds have a very high temperature and their heart rate also very high. So they have their own level of immune tolerance. So from species to species, the immunity differs. That is one thing. Any other such factors? If you go, even person to person, the immune system is different. Individually, we have different immune strengths, resistance. So individual factors, any other factors? Age. Just for babies and old people will have more prone to infections compared to the adults, right? Because of juvenile and it's over there. things are less in old age. Are there any other factors?
So generally people like the Europeans are more
Race is specific immune system. From race to race, there is a difference actually. For example, Africans are commonly, general statement, Africans are resistant to malaria because they have sickle cell trait. So yeah, race is one attribute. Any other factors? Vanshita. Now there are 5 people in the crowd. Yes. Any other factors? Environment. Okay. Have you observed that in the winter we catch more cold and flu infections? So because the temperature, when the temperature down, obviously the enzymal activity also diminishes slightly, leading to prone to more infections. So temperature is one factor. Any other factors you want to add? Nutritional status. Oh, very good. Lifestyle, nutritional. Now it's going out of balance again. Nutritional is one reason. Nutritional, malnutrition, lifestyle. Then if you go lifestyle is different from nutrition. Yeah. So these are some factors that contribute to immunity. Clear? So this is all part of innate immunity. Right? Then other one is cellular types of cells. Then membranes we had, systems we had, and others we had. All these are others. Then coming to the specific immune system. Okay. Specific immune system is also called as adaptive immune system. Adaptive immune system. To understand immunology better, I have experimented with multiple textbooks. The best textbook I felt was, it is actually Chandigarh Physiology, Essentials of Medical Physiology by Chandigarh. It has best introductory immunology actually. If you want to understand immunology basics, go with the Chandigarh. If you want to understand the depth of the immunology, go with the CP Bhavesh. And there is one more person, Panikar, one more microbiology textbook. Hashma not good. Panikar, one more person. Anant Satyanarayan, right? Anant Satyanarayan also has good. Panikar and Anant Satyanarayan together, right? Anant Satyanarayan also had good immunology notes. Anyway, overall, you will get better notes from Shambhalingam and from CP Bhavesh. That is sufficient. You can go to the Panikar for depth. Panikar has very good depth concept. Complement system. Anyway. Adaptive immune system. What is the meaning of adaptive? Something that it is adapting to the stress afterwards. So adapting can be adoption, specific. So acquired immunity. Very good. Oh, very good. Yes, you can appreciate that. Acquired immunity. Something that we acquire. Today Navjot looking like some villain character. Anyway, acquired immunity. Very good. Something we acquired. Okay. Now, this acquired immunity was broadly categorized into 2 types. Acquired immunity was broadly categorized into 2 types. Actually, I also want to, give another classification of BCC. That is cellular and humoral. That I will give later, okay? Fine. Let me. Yeah. So this acquired has 2 types. What are those? As you say, active acquired immunity and passive acquired immunity. Keep in mind the major difference between active and passive. I'm giving you here. See here. There is a pathogen. There is a breach in the skin. Pathogen entered inside the blood. Okay. Now The immune system worked over it. It recognized the pathogen. It did some homework. Okay. Then it developed the antibodies. Then it killed the pathogen. This homework requires around 1 week to 2 weeks to get a permanent immune, permanent specific immune resistance towards a pathogen. In a nutshell, the immune system recognized a pathogen. It did the homework. It understood the pathogen. Now it has the memory cells. Okay, it has the memory, and it attacked the pathogen. Such active participation of immune system in recognizing the pathogen is called as active immune system, active immunity, active acquired immunity. Why it is called acquired? Because now the system has acquired the information, its own information. It acquired not from the innate, not from by birth. It acquired through learning. That is why it is called acquired. Clear, right? Are you now John? Yeah. Then passive. No. Is there any circumstances where, or I will let you know, maybe my patient was HIV patient and his immune system unable to work. His immune system become weaker. It's unable to do the homework of understanding what is a pathogen. In such cases, at the end of the day, we need antibodies to kill the pathogen. So passively, we will inject the antibodies into the system. That is called as passive acquired immunity. Okay, passive immunity. So passive immunity means here antibodies are given directly. Immune system didn't involve, but antibodies came. That is called passive immunity. Whereas active means here immune system did the homework. Okay. Now these things are further divided into two types. Active can be done by two things: clinical and subclinical. Yeah, this is my test classification. Write down this. You can't get because I saw 2 to 3 textbooks to get this classification. Clinical infection and subclinical infection. What is the meaning of this clinical and subclinical? You got an infection. If you get signs and symptoms, that is a clinical infection. You got infection, but you didn't get any signs and symptoms. That is called subclinical. In either the cases, your immune system will be recognized. Okay, clinical or subclinical. Okay. Huh? Heart attack is something that is a different subject. Heart attack example. Something that involving in pathogen. Okay. Keep it as yeah. Fine. Don't confuse the class. You're going to metabolic disorders. Tomorrow I will continue. Okay. It's not time. Yeah. Thank you very much for your attention. Yeah.